Alright, how's it going there, pre-calc students? So, we are moving on to lesson 4-4, which is also, we're also going to be doing parts of 4-5 all at the same time. Anyway, we're going to be doing the graphs of sine, cosine, and tangent. Sine and cosine come from 4-4, and tangent comes from 4-5. There's other stuff in 4-5 as well, and there's actually even other stuff in 4-4. Anyway, we're just kind of cutting to the chase. Most likely going to do a worksheet here anyway, and it covers lesson 4-4-4-5. I just wrote lesson 4-4 up here in the corner. The good thing about this lesson, in a way, you did do this last year in Algebra 2. I know I taught it in my Algebra 2 class already before all this crazy stuff happened, so you have seen the graphs of sine and cosine and tangent, and we are kind of simplifying it this year, where we're not really doing anything new from last year. If we were actually in the classroom, I'd be doing more. But anyway, so here we go. What you see here on the left-hand board is I have a very abbreviated unit circle. I have only the things on there that I want, which are the key points at 1, 0, 0, 1, -1, 0, 0, -1. And I have only radians labeled. And that's because when you do a graph of sine, cosine, and tangent, you only use radians. Basically, the argument is radians are a part of the real number system, where degrees is a made-up number. And we don't, degree system is a made-up system, so to speak. Anyway, we're not going to get into that. We're just going to get down to business. So you will see here I have 0. That's 0 radians. Pi over 2, pi, 3 pi over 2, back to 2 pi. The first graph we're going to draw is y equals sine x. X represents the angle in radians. Y represents what the sine of that angle is. We're going to go old school at first, and then we're going to go back to just using, we're going to use common sense. We're going to use patterns and figure out how to draw these. So I have an XY table. I have the numbers I just mentioned over there for the x's, 0, pi over 2 pi, 3 pi over 2, 2 pi. That's one revolution around the unit circle. And I'm going to fill in this chart, and we're going to draw this graph. Okay? Now, the reason I put the unit circle up there is because the sines and the cosines are right on the unit circle. The sine question we're about to do, sine on the unit circle from previous lessons, sine is the y-coordinate, cosine's x. So I'm going to travel around to these 5 locations, and I'm going to say, what's the sine of this? You look at the y-coordinate. So if I start out at 0 radians, what's the sine of 0 radians? 0. Get up to pi over 2, which is equivalent to 90. So when I say what's the sine of pi over 2, it's the same as me saying what's the sine of 90 degrees. Sine of pi over 2 is 1. Over here at pi, the sine is 0. 3 pi over 2, the sine is -1. And back to the beginning, which is 2 pi, like 360, the sine of 2 pi is 0. Now, I have a graph here ready to draw. I have my x-axis going in the positive angle measurements. 1 rotation, pi over 2 pi, 3 pi over 2, 2 pi. Those are as evenly spaced as I did with my eye. I didn't measure it with a ruler. And they should be evenly spaced because each one of these is a quarter of a circle. Same amount. You'll notice in our y column the biggest number is 1, the littlest number is -1, so my y-axis is only scaled up to 1 and down to 1. So if I plot these points, 0, 0, pi over 2, 1, so pi over 2 up 1, pi 0, 3 pi over 2, -1, like right there, and then 2 pi 0. You see kind of this alternating pattern. You are to connect that with what's known as the sine curve. It is a curve. It's not a zigzag like a lightning bolt. It is curved. See what I can do here. And that's what that graph looks like. That's your basic sine graph. Okay? And every sine graph we're going to draw looks like that. So you should kind of now have that kind of, take a second to put that into your note page. Again, I got limited space here, so I'm going to pause, erase that, and do the cosine graph. I just want you to remember every sine graph looks just like this, meaning it starts out at 0, goes to the top, goes to the middle, goes to the bottom, ends back in the middle. It goes through a cycle. We're going to note a couple of things before I pause. There's two things about this graph that we mentioned. There's a thing called the amplitude. And for lack of a better explanation, like that's more of a physics term, but it's kind of representative of the highest point and the lowest point it reaches. The highest point the graph reaches is 1, the lowest is -1. We call the amplitude 1. Then we have this thing called the period of the function, which comes from the word periodic. This is a periodic function, meaning you're going around in a circle. So this shape is going to happen every time you go around the circle again. See, I can go around the circle 2 pi to 4 pi to 6 pi. The signs don't change. They're still going to be 0, 1, negative 0, negative 1, 0. 1, 0, negative 1, 0. They're still going to be the same sign. So that's why this shape would just keep happening and happening and happening. Periodic. That's what that means. A repetitive pattern. The period of this function is 2 pi, basically meaning 1 revolution around the circle is what it takes for that shape to happen. And I know you might be thinking, like, well, no kidding. If you go once around a circle, a pattern happens. You'll be surprised, probably not if you remember anything from last year. Tangent's not that way. Tangent is different. It doesn't repeat itself every 1 rotation around the circle. It does a different thing. So anyway, there's the given information about sine. In a couple of minutes, we're going to address that with these two examples over here. But right now this is like the parent function, the key function. This is what it looks like. I want to draw that parent function for the cosine. So we're going to pause a minute while I erase. Okay, we're back. Now it doesn't look like I did a whole lot, but I changed that to say cosine now. I did leave the amplitude and the period there in a minute because you are going to find out within just a couple of minutes. They don't change actually. I erased the y column of the chart and I erased the graph. I just put the regular x and y axis back there. So now this time we're going to rotate around the circle. We are going to do cosine this time. Cosine of 0, cosine of pi over 2, cosine of pi, etc. Please remember the same as what's the cosine of 0 degrees, cosine of 90 degrees, cosine of 180 degrees. Cosines are x-coordinates around this circle. So when I go to 0 at the beginning of the unit circle, 0 radians, the cosine's 1. See, already you can see the difference. Sine started out 0, 0, this is 0, 1. If I go to pi over 2, which is right there, the cosine is 0. Go to pi over here, the cosine's -1. Down here to 3 pi over 2, the cosine's 0. And back to 2 pi, the cosine is 1. You will see that the y column has the same numbers as in terms of 1s and -1s and 0s, they're just in different places. So as I go to graph this time my first point is at 0, 1. That's right here. Pi over 2, 0 is right there. Pi -1 is about right there. 3 pi over 2, 0. And 2 pi, 1. About right there. Also a curve, not a V shape, not a rigid V shape. It is a curve. Something to that nature, okay? Well, looks pretty good. Used to being in my classroom, my boards are a little higher. But anyway, these are low. All right, so that is the cosine curve. Now you will notice it's got kind of the same deal. The amplitude's 1, meaning it reaches a high point of 1, a low point of -1. There's that 1. And this same shape's going to happen again. When I got back to here and started going to here, to here, to here, to here, to here, to here, to here. If I just kept going around the circle, this shape just keeps happening. It kind of looks like the letter U, and that shape keeps happening. So that's kind of the basics to sine and cosine, what they look like. Now, to your right, we're going to start talking about, well, what changes happen. Because what we call standard information, the standard conditions of sine and cosine, amplitudes 1, periods 2 pi. That's standard. You start throwing numbers into the problem, and then things start to change. So the question on the table here is, what happens if I just chose the number 2 to talk about. What happens if there's a number in front of the sine? Excuse me. I don't care if this is sine or cosine. What happens if there's a number in front of the sine or the cosine? Versus what happens if a number gets stuck in front of the x? What does it affect? I'm kind of going to take a chart approach, but at the same time, I'm more going to talk about the chart and just draw the graph and tell you eventually what we're going to need to be doing. So if I was to get ready to graph this, so pi over 2 pi, 3 pi over 2, 2 pi. 1 high, negative 1 low. Now, I want you to understand that if I apply this, like order of operations is sort of important here. Because if I said here, do this table, make this chart, do this graph, you're still going to put 0 through 2 pi in for x. You're still going to take the sine. This comes last. You're going to do 2 times whatever the sine is, which, if I go back to the old graph now, I have to look at my old notes, where these numbers were 0, 1, 0, negative 1, 0, back to the previous screen that I had up here. That just means all those numbers are going to be doubled. So if I was to do that, please understand that normally sine starts out at 0, 0, times by 2, it's still 0. Now, I'm going to add this now. You're going to see in a couple of moments, I need to have a higher ceiling and a lower basement, if you want to call it that. If I go to pi over 2, you can see that the sine is 1. I need to times that by 2, so it's 2. So that point's pi over 2, 2. That's the dryer. Sorry about that. If you go to pi, the sine is 0. Times 2 is still 0. So that's right there. You go to 3 pi over 2. The sine is negative 1. Times that by 2, it's negative 2. So this goes all the way down to negative 2. And then this is back to 0 times 2 keeps it 0. So you get this effect. What changed? Amplitude did. The amplitude is 2. And I'm going to start calling that AMP for amplitude. So you guys, we're going to start the shortcut business like in our head right now, because like I said, we're not making these charts. We're going to end up shortcutting that. The number in front is the amplitude. It's the nicest thing about these graphs. What it says is what it is. No fancy stuff, no calculating, no garbage. That number is the amplitude. Now out here, you say, well, what about here? That's an understood 1 out front, which is why the amplitude is 1. Now, this graph over here. This one's going to be a little strange, but I'll show you how we handle this. I'm going to get the graph ready like I was going to draw it. Up 1, down negative 1, my marks here. Pi over 2, pi, 3 pi over 2, 2 pi. Now, understand something, people. You know what a sine graph looks like. It starts at 0, goes up, middle, down, middle. It does that alternating pattern, and it has to do that. Watch what happens here, because this 2 being in front of the x messes with me. I'm going to use these numbers and my unit circle over there to start drawing this graph. So, as normal, I start with 0 radians. Now here's the difference though. I put the angle in. I have to times the angle by 2 first. That's what that 2 there means. Then take the sine. Well, if I put 0 radians in there, times 2 is still 0. And the sine of 0, still 0. Now, here's where the math gets a little tricky. This is where it's nicer to be in class together and talk it out. But I'm going to do my best. The next number I would be putting in is pi over 2. Now, please think about this a second. What is 2 times pi over 2? I'll even put that right here just for a second. 2 times pi over 2. Please understand that that's 2 pi over 2. Like this is like over 1 for multiplying. 2 pi over 2, the 2 is reduced, it's pi. So this is confusing. I'm asking you to put pi over 2 in, but I'm really, because of the 2 in front, I'm really taking the sine of pi to do it. Because it's weird. I have to do 2 times my angle, pi over 2, times 2 is just pi. The sine of pi is 0. Here's the weirdness. I'm not supposed to go from 0 to the next spot being 0. I'm supposed to go from 0 up to a high point, then to 0. Boy, that didn't look very good, did it? I just noticed that. Anyway, so you're going to start to figure out, some people would think, hey, 2 right there makes the period twice as long. Nope. It makes the period half. Because when you put an angle in there, you're doubling it. You're making the angle sound bigger than it really is. So the graph happens faster. So I'll be adding a mark here in a second, right there. You're going to notice something else here when I go to pi. Because that would be my next one, is I put pi in. You can see right now if I put a pi right there, it literally says 2 pi. Sine of 2 pi. Folks, the sine of 2 pi is 0. And I know you're like, 2 pi. I was asking about pi. That's what's on the graph. But you got to go times 2. So then I'm back to 0 again. Now, you know your first 3 dots don't go 0, 0, and 0. Like 0, 0, and 0. That's the first dot, third dot, fifth dot. You can see the rest of this graph is going to be unnecessary. I need the marks here. Now, halfway to pi over 2 is pi over 4. And halfway between pi over 2 and pi is 3 pi over 4. It's kind of like 1/4, half, 3/4, 1. And here's the deal. If you put, because I haven't talked about pi over 4, if you put pi over 4 in there, 2 times pi over 4 is 2 pi over 4. Reduce that, becomes pi over 2. When I ask you about pi over 4, you have to take the sine of pi over 2 because you have to double it. The sine is 1. And you guys, the same sort of thing is going to happen here. This one's a little bit harder to do, but if you do 2 times 3 pi over 4, you'll get 6 pi over 4. 6 over 4 reduces to 3 halves. That's like asking the sine of 3 halves. 3 pi over 2, that is. That's where you get the negative 1. That's down here. So you get this graph. See, this one, your amplitude, still 1. The period of this function, which I'm going to start abbreviating PER, was 1 pi. Back over here, I should have mentioned this. The period of this function didn't change. It's 2 pi, standard business, but you should have it documented. So, you're going to understand, and I'm looking at this video. We're going on 19 minutes here, going towards 20. Not that that matters any, but you're now starting to see what's going to happen. The numbers in front of the sine or the cosine change the amplitude to that number. No calculating necessary, just is what it is. You're now noticing the number in front of the x, though, changes the period of the function, and we do need to talk about exactly what does it do. And we'll see if I might just stop this video and make a new one or pause this one, but make the next one talk about how we do bigger changes now. I do want you to understand, it doesn't matter if I had done these two examples with cosine. If these say 2 cosine x and cosine 2x, the only difference is it takes on this shape. Meaning, if this was a cosine function, my first point would have been here, 0, 2. Then the second point, then the third point, then the fourth point, and the fifth point. Starts up, ends up. It would have just had this shape like that. Same goes for that one over there. If it was cosine, it's the same calculation. See, amplitude and period are the same regardless of sine or cosine. But this one would have started up here at 0, 1. So that's kind of the gist of what we're going to do. I'm going to close. I'm going to pause. I'm going to kind of summarize some things over here. And then I might apply that to the next video, how we'll do that. We'll see. Let me pause here a minute. Okay, so I want to summarize here. And I wrote that over here now. Like I said, the nice part with the video, you can pause it, you can back it up, you can do whatever you want and take time to write things down. Here's the information. For your standard sine and cosine graph, the amplitude's 1, period's 2 pi. However, we look at this as being the main form of the functions. Y equals a sine bx and y equals a cosine bx. Meaning, we put numbers in the a position and the b position. Over here, I put 2 in the a position. Over here, I put 2 in the b position. And so I explained to you through these two examples that a is flat out the amplitude. So that's why it says the amplitude is a. Whatever is in front of the word sine or cosine, that's the amplitude. So that's why here, amplitude's 2. Here, it's understood to be 1. The period change is a little more complicated, but it's not terrible. If there is a number in front of the x, after the word sine or cosine, in front of the x, we call that the b value, and the period is calculated by taking 2 pi and dividing it by that b value. 2 pi because that's standard business. So if you kind of consider that over here, the b value is 2. 2 pi divided by b. The 2's reduce. We're left with pi. That's why the period ended up being pi. So the next video, I'm going to pretty much expect that you have this written down and you kind of keep it there at your side while I talk about different graphing now. Like, I'm just going to throw a bunch of graphs down or a bunch of equations down, and we're just going to talk about changing the amplitude, changing the period. How do I label things? Because you have to have the labels, the 4 extra labels, they have to be good. And we're going to talk about how we handle that. So that's part 1. Right now, I'm envisioning 3 parts. 3 videos this time. I mean, I know I could just make it one long video, but I don't know. It's just how I'm working. Like, I just don't want to sometimes sit here and talk that long. I can break it up. So I'm probably going to, the next video I've already told you, I'm just going to explore different amplitudes and periods and different equations and how we graph it. And then the last video will strictly be dedicated to tangent. You'll already have a good feel for how things go here. So dealing with tangent in terms of the mechanics of amplitude period type stuff, that you'll already have under control by the time I do that. So, all right, that's it for that one. Take care, people.